All right, so our next session is Biomanufacturing Skills Standards. Our presenter is Bridgette Kirkpatrick, Professor of Biotechnology Program from Collin College. Bridgette, you're up.
Hi, good morning, everyone. So just as a disclaimer here, this presentation is actually just a compilation of input that I got from Maggie, Jim, Linnea, excuse me, and Russ from all of the biomanufacturing skill standards that are kind of out there right now. So several years ago, I guess now, time flies when you're working hard. Texas implemented the Washington state skill standards. To my knowledge, these were kind of the originals for bioscience, and they covered the areas of research and development, regulatory affairs, and manufacturing. And if you go and you can look back at the InnovATEBIO website, and within this presentation that is going to be posted, I believe, at InnovATEBIO, all of the links to the skill standards and are within my presentation. So this bioscience skill standard, I don't think I have a pointer here, but oh, here it goes. Bioscience skill standards. This is the link to where all of those resources are found at InnovATEBIO. And I think there's a link to everything that I talk about from InnovATEBIO. And everybody, anyone interrupt me if I misspeak or you have something to add, please. So the NBC2, they have done lots of skill standards updates and works. This is a link to their homepage. They had the original in 2006, 2007, and those are broken down into these 8 different categories. They also have biofuel skill standards there. And as Jim and Maggie talked about yesterday, they are updating and reviewing some of the skill standards for the cell therapies. Excuse me, lost it there. And in 2013, NBC2 also did updated their biomanufacturing key activities, and those can be found here: the manufacturing technician, up and downstream, quality control, and maintenance of instrumentation. And they are now, as I just said, starting this. The grant team is starting to generate more skill standards for these gene therapies. And as Jim talked about yesterday, well, I'm going to finish on that, but these are going to, kind of be, they've started, I think they said they had five meetings so far, but how is this cell gene therapy going to be different than the typical biomanufacturing that we're used to? They also have done this core bioscience skill standards in 2016. So and this again is on a link on the InnovATEBIO website, and it's also linked through NBC2. What I thought was interesting, and the reason I've kind of separated some of these out, is some of them have a little bit different information for teachers to instructors to use. And what I liked about this is they have assessments that you can use incorporated into that the bioscience skill standards. How do I teach this, and how do I assess if my students can measure, if they can do pH? And so if you're like me, you always have trouble trying to, sorry, I have lots of pets. You have trouble trying to come up with a good assessment. And these assessments were put together by a team, and they've been vetted. And so I think this is a really nice addition for teachers to be able to use those assessments. The National Center for Biotechnology Workforce with Russ Reed. They also have several assessments here. They also have professional development workshops. I think I'm doing beta skills here in a couple of weeks, maybe sooner. I've lost track of time, I believe. And they have the links to these beta skills sets, or I mean, biomanufacturing skill sets at their website as well. And then they have them noted in the impact journals as well. What I like about this single page is it's really easy to add to your course. It gives students something to read and look at. If you give them a whole entire book, even a textbook, they may or may not look at it at all, but a nice one-page compilation of kind of what's expected of them and what employers are wanting. I think this is a really nice synopsis of that. And I think it's something that you can easily hand out to your students and have a discussion about that, and have with the expectation that they will look further into that. I try to add those the skill standards into my syllabus. And of course it kind of freaks my students out a little bit, but I think it's really important to add those on to the syllabus of this is what we're trying to accomplish in this course. And there's a reason, which is that the employers are really wanting that to see that in their students. And then, like I said, I'm going through this fast, so we might catch up. Biomanufacturing skill standards in gene therapy. This was the what Jim shared with and Maggie shared about the cell and gene therapy. And one of the new companies in Dallas and in North Carolina is actually doing a lot of that work with, Jim talked yesterday about kind of the tragedy of single or very few patients being affected by genetic diseases. And this company, Taysha, is starting there and developing a lot of new technologies and gene therapies for these diseases that with just a few patients. And so these skill standards are going to be more and more important. I'm sure that Russ is looking at these carefully, because these are that's exactly where unfortunately for me and Carol is the manufacturing portion of this is going to be in North Carolina, and the headquarters are going to be here in Dallas. But the skill standards and the quality component of this is going to be really important for our students to know for that company. So Jim's asked the question of what's happening, what's missing in the traditional biomanufacturing skill standards that people need to know for the gene therapy and cell therapy. And in their discussions, as Jim always is eloquent, top 3 skills are aseptic technique, aseptic technique and aseptic technique. And so that's something that is not terribly hard or difficult to get our students to learn, but the scale at which they learn it is going to be very, very significant. And the stories that Jim shared with us yesterday of you kill a patient if you don't get this right that's pretty significant. And so I think that getting that into your students' head that's how important it is. You're trying to save somebody's life. You don't want to kill them with something like a bacteria. And of course, we have examples of those out there of that happening and that's tragic, even if it's one life. So those seem like they're kind of simple skills, but it's paramount at that level. And so he also says the scale is different. Talked about how much virus you need and how to get the viruses. And then, of course, as he discussed, the chain of identity and chain of custody are really, really important. And again, thinking along the lines of, if I mess this up and, but when that can kill somebody, that's really very significant. And I think trying to instill that importance in your students. I don't know, somebody else can weigh in here, but more and more these days, I think in the chat earlier, people were talking about cheating and the gravity of that. And so sometimes I wonder of how difficult that will be to instill in our students how really critical and important that is. And so and also we talked about Nick talked about the cold chain considerations with the viruses, and I mean the vaccines to the COVID virus is very critical to what's being considered right now and how important that is. Sometimes I can't get my students to figure out the -4 from the -20, so to the -80. So I don't know if anybody else has those issues with their students or not, but mine might be special because they're Texans, but not to insult anyone. So I think that those things are really important. And again, the time element, as we were talking about, if you're in stage 4 cancer, how critical it is to make those changes and get those cells back to the patient as soon as possible. And so I think that kind of sums up some of the new things and critical things. And I think the other thing that was brought up was, excuse me, automation and how that is going to affect the supply chain and the work that the students are doing. So many of these things can be done by robots, but what are the other components that can't be, and how do people handle the automation portion of this? And actually, as ESO talked about yesterday, another consideration might be the in-place type of sterilization, as well as the disposable and the other considerations. I think that's all that I had for. I think now it's open for discussion, because that was the point of this, was to have a discussion of what other considerations might there be for skill standards in the upcoming techniques.
So, Bridgette, since we do both disposable and reusable, the skill standards and biomanufacturing skill standards don't specify a specific technology like a vessel. They're much more general than that. They specify more of a process.
Right.
So, and that's one thing I did ask Jim and Maggie a little bit, because Jim and Maggie have reviewed the Texas biomanufacturing skill standards that are based on what NBC Square did, which was Sonia. So they thought they were okay, but I thought, at any point, do we need something more specific in relationship to those skill standards? And then automation was actually discussed by our advisory board for our ACC biotech program, and they would like students to be familiar with automation, but then every system is different and they're very expensive. So I would be interested from the group here, how they address kind of generic training or education for automation, if there's anything. I mean, we require, of course, they have to do the FPLC, they have to do, it has to be linked to a computer. And then the other thing is the LIMS system. So one thing, the skills standards, so Washington skills standards did require the updated ones that you have a LIMS system in your educational program that students could become familiar with.
I can weigh in on that a little bit. Actually, Todd should weigh in on that. You want to mention something? So
Yeah.
Todd is working with a group
Oh,
at
here,
the University of
out
Washington.
of the fog. Whoa. There we
You
go.
can talk. I'll go get coffee.
Yes. Yeah. So I've been working with a group, talked to, let's see, Nick about it and Ying Su. But yeah, out of the University of Washington, it's an open source LIMS platform that, has grown out of synthetic biology, but being open source, one of the key features about it is the thesis was having a system that would provide instructions for technicians, right? So one end, there's a coding aspect where you put in protocols, but on the front end, when people interface with it, it has work lists and it has instructions, very specific instructions, how to do things in the laboratory. People often refer to these as slides. And so I'm working with them to secure grant funding. I'm thinking, ATE kind of project in the fall should be submitted, and other kinds of activities. So that's been something I've been working on for the past year or so in my my consulting practice, as it were. Yeah.
So you're going to submit an ATE in this then, you're saying?
Yes. Yes.
Oh,
right now
good.
we're doing some general cyber infrastructure grants to NSF and also NIH. So one of the labs they work with in Washington is the Institute for Protein Design. So for those who are familiar with that or not familiar, briefly, that's David Baker's lab, and that's the lab that's creating all these new kinds of
At least 6 companies have
yeah.
spun out of it.
protein molecules, and with each one is a new company. It's kind of a wild place. So they just submitted that, and so really their summer exercise is literally grant writing. So and I want to get them involved in ATE.
Oh, so I figure you're partnering with the center since you're part of the center. And out of curiosity, have you picked community colleges to be part of this in terms of piloting this or anything? Maybe some of the group on this call would be interested.
This is a great time.
Don't you like how I just push you?
Yes.
Who wants to volunteer to be?
No, this is a great time for people. George, we need to reconnect because we were going to talk about it. And then, I don't know, your world changed briefly, but it seems like you got things back in order. So, and I'd love to see them involved in iGEM because I think they could support all the iGEM projects because those are so heavy on synthetic biology. I mean, their primary use case is I'm going to make 1 million plasmids and then I'm going to go test them. Right. And, and if you think of synthetic biology, it's I'm going to make 1 million plasmids and then I'm going to go test them. I never, I thought I was getting back to, my molecular biology roots in a big way when I started working with folks, because it was like, wow, plasmids and transformation and vector construction and, and all these things that we learned, 30 years ago. It's just the only difference is now we're doing it at big scale with instrumentation, with automation, parallelization, and LIMS.
And high school students can do it.
Yes, they can do a lot. Yeah.
Linnea, for LIMS, we should take a look at bench learning. I think it's emerging as a dominant platform. Plus, they, I think, are offering it us for free.
Yeah, I've been using BenchLink for years, and it's the go-to now for me.
Yeah, BenchLink is another. That's kind of that always. Every time I bring this up, BenchLink comes up.
Yeah.
So what?
Yeah.
The other thing is for automation, I'm on a project through Nimble called Spider.
Oh, yes.
And we've developed, well, they've developed about 35 automation modules that are on the International Association of Automation Engineers. It's behind a paywall. You have to be a member, but as part of that, we're going to do a train the trainer when things open up on using Emerson Delta V system. And we are getting a major training module. It's a $150,000 module this week. And so we'll have you all come out when that's installed.
Yeah. So, yeah, I mean, what you described, Jim, is I think really great. It's how does that become scalable to a lot of schools and a lot of training. That's kind of, and I'm gently or not so gently, for those who know me, trying to get the aquarium team to think about, a true open source LIMS platform, because even Benchling is closed. It's a closed environment. You're in their cloud.
Exactly.
Once your data's there, okay, it's Benchling. It's Benchling. Let's hope let's just hope the investment thesis makes sense, because when they get bought by they've been so invested in, and their revenues are behind the investment, that all of these LIMS companies really kind of struggle with that piece. So
and we only have,
I think we need a solid open source alternative.
We do. Yeah. And Benchling we only have access to this sort of lab notebook academic side, and we don't have anything that like a startup or any validation, none of that.
Yeah. And so, but what we really need to do is have a community working with the aquarium team. Without that, then it's just kind of a struggle for those guys, and so.
Well, Linnea had a great idea, which is a separate meeting to talk about all this.
Yes.
And InnovATEBIO will gladly sponsor that, because it could lead to an ATE. And to be honest, if you want that ATE to be successful, you'd need input from both industry and community colleges on this, right?
Yeah.
So why don't we do it? Okay.
Yeah.
And if you guys are interested, then you're going to attend the meeting, right? All of you.
Sure.
Hey,
Yes, Mom. Yes, Mom.
Hey, Linnea,
I'm gonna adopt that, George.
you guys mind if?
Okay, wait. Tom wants to weigh in.
Yeah, I've been working with a group down in North Carolina that's implementing Delta V, and you're talking about automated process and automated manufacturing, and this is a major concern for a lot of folks in thinking about the future of workforce for biomanufacturing, and what does it actually look like. So I think that you're absolutely right. I think it's a great topic for a separate meeting, but we also have to consider, as we're moving forward, a lot of other factors. We're talking about expanding the scope of what we're traditionally thinking about biotech into a lot of other disciplines and the Internet of Things and computer programming. And so a lot of us are not necessarily comfortable with that. We've got to break that discomfort barrier, not just within our programs, but also with working across the board with universities and thinking about things like what Celeste just announced for the IUCRC and the university industry partnerships, leveraging all of these things so that we can move a little bit faster. So that's all I'm saying. I think that this warrants a larger discussion, and I think it's an important one to have.
Yeah, so we'll have to have that one. There is an ATE in North Carolina that is doing their second ATE, and they're going to expand Delta V to open more to the the community.
County Community College or Johnston Community College?
Yeah.
Johnson Community College.
Yep. Yeah, I had talked to the PI about that, and I said that the center would gladly disseminate that and help her do that. But yeah, so you may not know that, Jim. So see, we need more conversation because we're all working on the same thing. We just don't know
I do know that. And I also know that the BioNetwork system just acquired 2 Delta V systems for their statewide education. So
Okay, so the heads up with that, the licensing for Delta V is going to be cost prohibitive. If you guys have looked into it, it's insanely expensive for the licensing for the software.
It has to be. Yeah.
Well, anyway, obviously we need a conversation both on LIMS and automation.
Yeah. And there's a really great podcast, Luke Timmerman and who is it?
It's called The Long Run. I'll put a link to it.
Yeah.
Okay.
It's Luke Timmerman.
And he interviews this woman whose name's escaping me. but she has a LIMS.
Daphne Kohler.
No, it wasn't Daphne Kohler.
Okay.
No, it was the LIMS for Providence.
Oh, the LIMS person. Yeah.
Yes,
okay.
the LIMS person, and she came out of GE, financing and that group, but they're going into these companies on CAR T and changing the conversation. If you go in and you don't have a data management plan that does that provenance correctly, FDA doesn't want to talk to you.
That's right.
Because
great podcast. Yeah.
Because it's all about making sure that,
chain of custody.
Yes. Aunt Millie's T cells get back into Aunt Millie. Right, Jim?
Yeah. So anyway, Sandy and I will organize that meeting, right?
Right.
Yeah.
Okay. And we will make sure you're all invited, and anyone you want to invite or bring into the conversation will also be invited. Okay.
Yeah. And just, so, my background in LIMS, I had basically a LIMS company for
we could have
quite
somebody,
a few years.
People could demo Aquarium. We could have somebody demo Benchling.
Yeah.
Demo Delta V and Spiber. So all four, right?
Yeah.
And Jim, I'll make sure that I'll tell John. Okay. And we have Tom on the conversation. So we have the EWD director for Biomade.
Biomade too, because that's
it's all synthetic biology.
So if you go to the EBRC page, you see names on there like Eric Clavens and James Crothers. They're all at UW, and Aquarium came out of the Clavens lab.
Out of the Biomade people, actually.
And so it's running the biofab lab there. That's a whole nother concept in synthetic biology, biofab. Yeah.
Anyway.
So many words. So, all right.
Yeah,
Hey,
we all
can I
just
give
need
a-
to be cloned. Yes.
I'm going to give a shameless plug for something, since you guys are talking about having meetings. And I think this is directly aligned with what you guys are talking about, what we're all talking about for biomanufacturing. So Jim is giving our keynote speak for our coordination network meeting, which is integrated in with the World Stem Cell Summit on the 18th. And we have a 3-hour chunk of time where we're coordinating our NSF work and also some of the representation for the center with the World Stem Cell Summit. It's going to bring in a huge crowd focused on workforce development for biomanufacturing. If you're interested in being a part of the conversation, I'll drop my email in the text box, and just send me an email. And if we have any registrations which we're able to provide for you, we'll get you into that meeting. We have a limited number of registrations, and we would love to have you guys share your input about automated manufacturing and everything else under the sun, because this is exactly what we're talking about, and it'll roll into future conversations.
Yes, please take him up on that. It will be really worthwhile. So serious. Otherwise, you'd have to pay, and this will be worthwhile. Targeted meetings and getting cloned. See what happened, Bridgette? You wanted time for discussion, so.
I did. I think that's great discussion too. I mean,
yeah.
And if we don't have these as part of our courses, at least touching on them, we definitely need to.
Yeah. So I always say, as Sandy pointed out, national conversations are worth going to. So.
Yes.
So
yeah, cool.
What else, guys? I don't know where we are on time or where you are, Bridgette. It just, you got slurped. But thank you, Todd. We appreciate that.
No, that's perfect. That's exactly what we're supposed to be doing here, right?
Yeah.
Thank you so much, Bridgette. This was good. This was great, and it led to some good conversations and plans for future meetings and so much more. Thank you again.